Right, welcome everyone. It's 10 o'clock, it's Monday, so it must be Khronos fast forward. Woohoo! So, the next 90 minutes you're going to know everything about Khronos that you wanted to know, and probably some of you that you didn't as well. So, I've got lots of good speakers, lots of working group chairs to give you all the insights that you need on all the good stuff that the Khronos group is doing. As requested by the SIGGRAPH organisers, if you want to take photos, you're very welcome to, but we're going to be uploading all of the videos and the slides to the event page, so you can go check it out. We'll try and do that as fast as we can after the day is over. So, if you haven't come across Khronos before, we are an open standards organisation. We're a non-profit. Every non-profit has a particular focus. Ours is creating low-level APIs for connecting software to silicon. That includes 3D graphics, XR, compute in various shapes and sizes, including machine learning. And we're going to be hearing all about those throughout this session today. But today is actually a special BOF for us at Khronos. Khronos was founded in 2000. And so this is our 25th SIGGRAPH BOF, and so I can't believe we've been doing it this long. And as you can see some of the standards that we've created over the years. I see Kurt is here. Thank you, Kurt. Kurt is here. Stand up, Kurt. OpenGL was the beginning of this incredible journey. We put OpenGL in 2006, but of course it was in 1992, and it came into Khronos in 2006. But as the president who's been elected every year throughout these 25 years, apart from the very first year, I just want to take the opportunity to say it's a real honor and a pleasure to work with everyone in the industry, both inside Khronos and outside Khronos, in creating these open standards that the industry needs. Everyone, thank you. You're making a real difference in the industry. Good stage back, thank you. So, one way of looking at the Khronos APIs is the new term is spatial computing, how we're going to bring AI and spatial awareness to all of the computing graphics that we do. But we actually have an API for pretty much every point in the spatial computing pipeline. We have a new Khronos API, which is in development for dealing with the sensors. We have a family of compute APIs, vision and inferencing. OpenXR, which has become the basis standard for dealing with AR and VR hardware. And of course, last but not least, all of the 3D APIs that we have, WebGL, OpenGLES, and the new generation Vulkan. We have WebGL that brought 3D to the web. Now it's been upgraded to WebGPU, working with the W3C. We have the new Slang shading language, and we have the glTF and KTX container formats that bring the assets that we need into those 3D APIs. Now, we have people here that know way more than me about each of those, but apart from Khronos, I'm the chair of the Khronos working group. We've been working on it for a while. I'm going to just give a 2-minute overview on Khronos because we're getting to a pretty good point in its development, and we'd love more people to get involved. So the Khronos scope is dealing with a piece of hardware that we haven't had an open standard API in the industry for before. It's the camera module, including the sensor and the ISP. That's the image signal processor that's close to the sensor that's doing the processing on the images. They come in through the sensor before they go downstream into the compute APIs that we have. Khronos has had a lot of requests to fill this gap in the open standards pipeline. It's actually an interesting challenge because camera and sensor hardware is very different to GPU and DSP hardware, and so it has its whole set of interesting challenges, but we're committed to hopefully make a positive difference in the industry. We've been discussing this since 2021. We got the working group up and running in 2022. We've been heads down designing the Khronos API now for a couple of years. It's a ground up exercise. It takes a couple of years to do this kind of thing. We are planning, fingers crossed, touch wood, to get the spec, 1.0 spec out in 2026. We're going to have draft specs in the next few months. So if you're into sensors and camera processing at the very front of the pipeline, please do consider getting involved. There's a couple ways. Of course, the best way is to join the Khronos group. Anyone is welcome, and you can have a seat at the table as we do the actual design. Or, if that's too much, we have an advisory panel, which is free of charge. Anyone is welcome to join, and we'd be happy to share drafts and take your input through the design process. So, that's the cameras pitch. So, thank you to all the speakers who put a lot of work into preparing the slides here. We have Ralph, who's the chair of Vulkan, Shannon, who's the chair of Slang, Markus, who's the chair of the ML Council, doing lots of machine learning exploration, which we'll go into. We have Bill from ANARI, Denny from OpenXR, Leonard from glTF and 3D Commerce, and last but not least, Ken Russell from Google for WebGL and WebGPU. So without further ado, and everyone has exactly 8 minutes. I've gone 1 minute over, so I'll try and keep everyone on track. So, Ralph.
All right, so hello everyone. I'm Ralph Potter. I work for Samsung. I'm the Vulkan Working Group Chair. So Vulkan is an explicit API for graphics and compute on GPUs. And one thing that's been new over the last probably couple of years is we've now got sufficient roadmap to actually start driving the evolution of graphics hardware for us to collaborate and talk about what we need in the hardware to make the API work the way we want to, rather than just reacting to the hardware as a static thing, which is a great place to be in now, and I'll talk a bit more about that as we go on. So Vulkan is everywhere. We have implementations on every major GPU. We have a wide array of content, both on desktop, on mobile, professional graphics. We're supported in all the major engines. There's a healthy kind of ecosystem of middleware and the like. And I would say like, Vulkan usage is trending up, particularly in mobile, but also I'm seeing more and more professional graphics apps also using Vulkan. So one big thing for this year, or December last year, we released version 1.4 of Vulkan that integrated some important extensions. Bringing dynamic rendering local read means that we can now do pixel local dependencies without subparses and the old render pass API. That makes things a lot more ergonomic, a lot more dynamic and friendly to work with. We guaranteed that there would be a path to do streaming transfers, so if you're doing like open world game content, that's important. And a bunch of other extensions. We pulled in 16 extensions, and then one other thing that we had not really done before in the history of Vulkan was to increase the minimum limits, so the minimum bar for what hardware could support Vulkan. Vulkan's nearly 10 years old now, but this was the first time that we'd raised those limits. Which I guess I've covered here. So Vulkan 1.0 was designed to support GLES 3.1 hardware. That was 2014 hardware. It's more than a decade later, but this is the first time we've done that. I also want to talk about kind of how we structure our work. So we now essentially have two major deliverables, both on a 2-year cadence. We deliver a roadmap, which describes kind of high-end or new, maybe not high-end, mid to high-end GPUs in the year of the release. It won't be everywhere, but all vendors commit that they will have a part that supports that. It's kind of directional. If you see something on the roadmap, we're saying, we believe this is the future. And then the core is intended to be a wider scoped thing. So when cores come out, we expect it to be implementable on all kind of current devices, or at least things that people are selling, even if it's part of their back catalogue. And based on this cadence, you can expect us to release another roadmap somewhere early 2026. And I don't see any reason why we won't hit that roadmap. So we have a BOF on Wednesday, where I'll have a bit more than 8 minutes to talk about what we're up to. Please come see us in the Fairmont Hotel, 4:30 till 6. I'm going to cover basically all of these topics very briefly, but yeah, agenda is there. So one thing over the last, I would say, couple of years, we've been working quite hard on developer experience in Vulkan. Vulkan is nearly a decade old. We've learned some things. We made some design decisions in 2015 that were either constrained by the hardware of the time, or we made some bets on the future and they haven't all panned out, or we've just come up with better ways of doing things. So the API has evolved, but the old things haven't gone away. The API surface is now large, and it's becoming complicated to communicate what you should actually be using, what we recommend, what things we regard as legacy. And so we're working really hard both on making the API more ergonomic, more friendly to use, and on communicating what we regard as legacy and what we regard as our bets for the future. We can't solve that with one thing. There's a whole bunch of little bits and pieces that have to come together for that. Some of it is new extensions that we hope migrate down into core. Some of it is education and outreach. That's teaching people what we believe they should be using in 2025 rather than what the documentation said that you should use in 2015. We've been working to modernize documentation, modernize our samples to represent best practice. One big thing is we are starting to formally tag things as deprecated. Now, nothing is getting removed. We have no plans to remove anything, but we want to communicate what we regard as legacy and what we regard as forward-looking. Other talks for the BOF, and this reflects on kind of usability. Karen will talk about the Vulkan SDK, what new things are in there, what updates have occurred there with all of the tools that we deliver and ship. Vulkan is not really just a paper spec. There's a whole raft of tools and a big ecosystem to go with it. The SDK is a critical part of that. We also have Vulkan Safety Critical, which is a safety critical version of the Vulkan API. It's not exactly the same. There are some changes that have to be made in order to fit functional kind of safety constraints, but it's derived from Vulkan 1.2, and it's fundamentally Vulkan with some relatively small changes. So Andrew will be talking about that. We have a great talk from Autodesk. So they've added Vulkan support to VRED, their visualization tools, and to Alias. So they'll be talking about those, also a little bit on Storm and Hydra. So I look forward to that. And also this week, in addition to our BOF session, we also have a hands-on lab session on Thursday. That's 11:45 in the lab in the West Building. That will be looking at Vulkan ray tracing and dynamic rendering. So we'll provide some scaffolding code, and then the lab will take you through implementing ray tracing with shadows and reflections, and basically filling out some Slang code to get all of that working. So that's also something to look forward to, and I hope some of you will be there. And having mentioned Slang, I'll pass this over to Shannon.
All right, hey everybody, I'm Shannon. I'm a technical program manager at NVIDIA and also now the chair of the Slang working group at Khronos. We're the new kid on the block, having just been accepted as a working group late last year. As far as what Slang is, if you're not familiar, Slang is both a shading language and a compiler that takes that shading language and can compile to a bunch of different targets. If you're working in DirectX, you can compile to HLSL. You're working in WebGP, you can get WGL. You can compile direct to Sphere V for Vulkan or generate GLSL if that's your thing. We support metal shading language. We even have support for targets like raw C if you want to run on the CPU, or compute specific targets like CUDA and optics. But that's not all that Slang has to offer. Slang also provides a bunch of cool modern programming language features that are first in the shading language world, like generics and interfaces that you might be familiar with from languages such as Swift or Rust. Basically adds a lot of stuff to the shading language that make it much more comfortable and ergonomic, as well as providing some compile time benefits. As I mentioned, Slang was accepted as a Khronos working group in late 2014, or 2024, sorry. That move brought some important things to Slang, namely bringing Slang under multi-company governance and allowing us to truly operate as a widely open source community project. One thing that is different about Slang versus some of the other Khronos working groups is that Slang's technical development is all done in open source. So we're making our decisions on GitHub, in our Discord, and you can take part in those. You don't even have to be a Khronos member. You can just come be a part of the project. And we've been growing a lot. This graph is in fact even a couple days out of date. We now are sitting at almost 4,400 stars on GitHub, which has surpassed our peer shading languages. So we're humbled and excited by that. We also have, on the Discord that I mentioned, we're approaching 800 members. It's very active. We have people asking questions and starting technical conversations every day. So I encourage you to take a shot of this QR code and join us on the Discord if you have ideas for the Slang language or questions about how to use it. That is your go-to. Also, I mentioned switching or moving into Khronos for governance has helped us really move into community-guided development. Over the last 6 months, we have over 50 people who have made a contribution to Slang, more than half of which are outside of NVIDIA, NVIDIA being the place where Slang started. So more than half of our contributors are now from outside the original set. And you can even try Slang out right now on the web by going to try.shaderslang.org. We have a web playground that runs on top of WebGPU where you can execute code right in the browser and even get IntelliSense-like features thanks to Slang's language server running on top of WebAssembly. It's pretty cool. You can also check out all of our docs at the link down there. So a lot of cool things are coming out of the community. We're really excited to see some of those. Since our launch at Khronos, announced at SIGGRAPH Asia last year, we have welcomed 3 new committers. Committers are essentially people who have come into the Slang community and have been granted access to independently land changes. So these are our technical stakeholders. And in addition to just making small fixes, they also propose and guide language features, and we consult with them when making changes to the language. These new committers, I think 2 of them are even outside of Khronos, and all of them are outside the original NVIDIA team that started Slang. We have an active or a growing subreddit that is moderated by our volunteer moderator Simon. Big shout out to him for his work there. And then some really cool stuff that's been developed in Slang over the past few weeks and months. There's a team writing a procedural planet generator in Slang. And they use the Slang Playground to put out a demo. Basically, you can go to their website and do a one-click copy, come over to the Slang Playground and paste it, and see it running in your browser, which is pretty cool. They said they chose Slang because of its auto-differentiation features, which I neglected to mention when I was running down the set of Slang features. Probably the most interesting new feature that Slang has is automatic differentiation, which is a key underpinning to neural shading, gradient descent techniques, stuff like that. So if you're interested in connecting AI to graphics, Slang is the one shading language that has that built in. And then also, I couldn't go through this fast forward without mentioning that Sasha Willems, who, if you learned Vulkan, you probably learned it using his tutorials, has added Slang shaders to all of his tutorials. And he wrote a nice blog post talking about how easy Slang was to use and what a joy it was. We've also been doing a ton of work on developer outreach. We wrote a developer blog that goes into the beginning of how to do neural graphics. It walks you through from a very beginner perspective. We've got a bunch of virtual community meetups we've done. There's an upcoming meetup that talks about Slang modules and how you can use them and what benefits you can get out of them. It's everything from organizing your code more easily to actually getting compile time benefits. And you can register using this QR code. We also, Slang integrates with the tooling that you're probably already using for Vulkan. It's supported by RenderDoc and Nsight Shader Debugger, and very recently Aftermath has added support for Slang to its crash debugging, and we just launched integration of the Slang Playground into the VS Code extension, so you can now be running inside VS Code, hit, I believe, Control-Shift-R, and bring up a pane that runs your Slang code right there in the web playground, but locally. So all of this and more is going to be, we're also going to have a couple of talks from people and companies who have used Slang in their real world products, and we'll talk to you about the things that they've learned using Slang. And we also have an in-depth talk about where Slang is going in the future, what the roadmap looks like for Slang from Yong He, who is one of the language architects. So I'm really excited about that. Please join us on Wednesday.
Thank you, Shannon. And whilst Markus is getting set up, we aren't going to have time at the end for a Q&A. So if you have questions for any of the speakers, keep those questions in mind. We will get right to you at the end of both talks.
Hello, I'm Markus. I'm DevTech at NVIDIA in the Probe space, and our team helps our independent software vendors to integrate machine learning as efficient as possible into the applications. And in this position, I decided to get ML Council Chair Khronos to support Khronos finding a way to more efficiently help with open standards to integrate machine learning into applications. So, what is the ML Council? Within the ML Council, we are a working group to discuss the challenges in cross-platform ML development. We don't want to have ML only on Windows or only on Android, so that you have to write your application only for one specific target. We want to ensure that you have one target that runs on Windows, Linux, Android, whatever you are so interested in, as long as there are Khronos APIs. We also want to promote the exchange of knowledge within the ML domain within Khronos to ensure that all our members understand the needs of ML, so what do you need to do in your hardware to make ML more effective, so that they can ensure that the next hardware generation will run the current MM workload as efficient as possible. And we also want to provide some kind of industry consensus on effective ML acceleration directions, so even guiding, if necessary, platforms like PyTorch to give them ideas what might be changing in the future. And we are quite interested in input to the evolution of existing API standards and extensions for machine learning so that we can improve. And of course, all the feedback we are gathering, we are giving back to Khronos members and API implementers of Khronos standards. And so, ML Council got mostly revived half a year ago, and to begin our work, we have started market research to understand the current ML market. We really want to understand the hardware and software ecosystem for machine learning and how to get acceleration as efficient as possible onto as many different hardware architectures as possible. And we see this as opportunity for standard bodies like Khronos to advance acceleration of machine learning onto more hardware platforms more effective. And with this goal, we have talked to a lot of different people that one-on-one interviews with AI model experts, product builders, hardware makers, AI compilers, tools, and even other communities and standards to get an as wide input as possible to what are the problems inside the ML ecosystem so that we might suffer getting a wide deployment of machine learning software on as many platforms as possible. And yeah, we really want to know what problems does the industry face and what solutions they consider as viable to implement them in their platform. And so the details for this we will be presenting at the concept of, but the generic output is like there are two different ways to do ML today. Either you're going to a compute hardware acceleration layer, like Vulkan Compute, OpenXR, and the library or the app developer is responsible to take care of every single kernel, every machine learning operations, while on the WebGL on the other side, the independent hardware vendor or the driver developer, if it's an open source driver, is responsible to take care of everything. But there's a wide range of disjunct features which work well on the computer, but which doesn't work on the graph file or vice versa. So we have really two opposite ends of a problem, and currently there's nothing which merges those. So if you're using a computer, you need a lot of expertise to optimize the shaders, and if you're optimizing the shaders, well, the performance might not be portable because we have so many different hardware architectures, and I will talk a little bit of problems above, that you will have to write a shader 10 times to get efficient support everywhere. Well, if you're running compute, you might not support NPUs, and if you want to do any kind of optimization of Fusion, unless you're using a compiler generating a computer like IRI or TVM, well, you have to write every operation on your own, so you need even more developers and expertise. But why people like it, you get predictable performance on the platform you're interested in, which is a good and bad thing at the same time, and you can have your custom operator set. On the graph file on the other side, if we would have a graph hardware abstraction layer, you don't need that much expertise to use it. You know your machine learning operations. Well, you write a graph, you export it from PyTorch and everything once. And for the performance, well, the idea is that higher level ops are more portable because you're taking away the control. People want to have in Vulkan, but maybe not machine learning. And this makes it more future-proof because if there's a new hardware, there will be a new driver, and the new driver knows the hardware exactly and can provide the best possible implementation. If you have NPUs and high-level ops, yeah, you can support them. Fusion, it's all graph compiler work. It could be done on the computer as well, but maybe not as efficient for the hardware. For predictable performance, I put in a maybe, because you are now relying on the hardware vendor to have a good driver, and because everything is more high level, it's not as easy to understand all optimization strategies the driver might do. And well, in a graph, you have fixed operator sets. What do you do if you in the operation it doesn't work? So you have to switch between graph, compute traders graph. So you have two different sites, and the question which we are asking now within the General Council group is, can we make a hybrid? So could we make a hardware abstraction layer which has the features both of the compute web, hardware compute hell and the graph hell at the same time? We don't know, but we need your input if we would want to have such a help, and if we would be happy to rely on a driver developer to provide you operations in a compiler, because they're not giving you the same guarantees as a Vulkan hell, but also they're providing you more performance portability in the future. This is something people are interested in. We really need your input here. And the vision we developed for such a hybrid API would be that we define some kind of graph language. But the graph language itself shouldn't have just tensor operations, like PyTorch, but we also need some kind of tensor shader. Some shader you can put in a tensor and you get out a tensor, and then you need to do shape inference and everything you would be doing within PyTorch. We have NNEF 2.0, which defines ScriptND, which is something like the tensor shader. We might be able to use this, for example, to get to such a graph language. And at the same time, if you have such a graph language, you can define tensor operations at a higher level. Use a lower level language to support them. But first, before we get there, so the graph language would be compiled to something like a SPLV graph. SPLV is the IR we are using to communicate with our drivers. And this SPLV graph would include tensor shaders and tensor operations as well. And now you would be loading this one into something we call SPLV runtime, SPLV ML runtime. If this runtime would be in Khronos open source projects, and the goal of this runtime is to decouple drivers to support requirements from your application. Currently, Khronos gets a new hardware feature or members, and they propose an extension, and then we have to standardize, and it can take extremely long to get the standard done. And ML is moving super quick, so we don't want to wait until each and every IAG potentially can support a new driver. Some are faster, some not, but that's fine, because everyone has different needs. But we want to have an open source project which would implement the standard we are defining, and it will get the SPLV machine learning hell, and then it checks, okay, does the driver support this new SPLV machine learning hell? And if the driver doesn't support it, this SPLV ML runtime would be responsible to lower everything to SPLV compute, and SPLV compute is supported by every Vulkan hardware you can imagine, and then we pass the SPLV compute to the driver, and everything is fine, the application runs. And if a hardware vendor would decide, okay, we support all those operations, it still can decide to support only the tensor shader, but not the tensor ops. And the tensor ops, we would have a standard library defining ops, and those would be lowered to a tensor shader in case the driver doesn't support those ops, and then we go to the driver again. This would allow us to move extremely fast with an open source project, but at the same time we would allow IAGs to decide what they want to support and at which pace they want to support new features. And we're trying to evaluate industry consensus if this is something the industry would be really interested in. And so if you're interested in the story I told you and you want to know how we got there with the research project and want to get more insights and also understand why performance portability in compute shaders might be a problem, join us at the Council BOF on Wednesdays, 3:30 p.m. directly after the Slang BOF. And now I give the talk to Bill.
Thank you. All right, so I'm Bill Sherman from NIST, and I'm here to talk about the ANARI API. And as I'm not the chair of the working group, the chair couldn't make it this year. That's Jeff Olmsted's I kind of represent the user community more than the developer community, so I'm more at the higher level. Anyway, so I mean, it's a classic need for Khronos here, right? We have all these applications and all these different rendering technologies. We have, science applications, animation applications, and specific science applications, and so on. And we want to bring that together so that we have one common API to go to different renderers. This is a partial list of our existing backends right now. Intel's Osprey, Vision Ray from Stefan. I don't know, Stefan might be in the room if he got. There he is, all right. And NVIDIA, and also Cycles from Blender and others as well. There's also some specialty ones. There's a remote rendering one, things like that too. So lots of different backends that you can render to, which have different capabilities. Some run better on different GPUs, etc. So the working group was established in the auspicious month of March 2020, and the first spec came out in November, about a year and a half later. I joined the group about that same time. Oops, sorry, Leonard. And then another year and a half or so, and we launched 1.0. We're in the process of just now coming up with the 1.1, or finalizing, I should say, the 1.1 specification. I think it's before the board now, or just was. So we're hoping to have that out in the fall. Here's some examples of new stuff that's going to be in 1.1. So a couple of these were inspired by USD. So having attributes associated with mesh faces instead of vertices is one example from USD. Another one is this instance transform array. So if you have one object and you want to have thousands, millions of them, and you just want to specify their 4x4 matrix for where they are or other attributes on them, you can just specify the attributes and have a lot of those instances. We have implicit isosurfaces as a new one, so that you don't have to go through a mesh geometry or some other in-between geometry. You can go straight to a ray tracer or path tracer renderer with an isosurface. It might take a little bit more time, but you're saving the whole step of having to store the mesh, right? On the far upper left, my left, your right, NanoVDB is another extension that we've added, and basically the extension there is that you can just take a NanoVDB data set and shove it into an R. You don't have to parse it, send it as some serialized form, and then unparse it again, right? You can just send it as raw NanoVDB data. And finally, one of the big new features is the integration with MPI, where you can do data parallel rendering in large data sets. The paper there is from Ingo et al., Engelwald et al., who just got the award last night for the time-honored, what was the name of the award? Test of Time Award, yes, thank you. Oops, wrong way. All right. So a couple of things that we've been doing in the working group is, of course, we have a CTS to make sure that backends meet the API. But we've also been working, we put out a call for bids, and Kitware implemented the CAT process, which is more the evaluation of backends. So if you have a certain thing that you want to perform in your tool, you want to know which backend maybe does that best, right? And so this tool, this CAT tool, helps provide that information for you. And so that's pretty much all I have. We will also be doing an ANARI BOF, where we'll go into more details in some of these things, and ours is at 1 o'clock on Wednesday. So I'll be here for questions at the end of this session.
Hello, everybody. I'm Rönngren, and I'm the vice chair of the OpenXR working group, also employed by Varjo, who makes XR headsets. So today I have the honor of giving the task forward, and we've been very busy during the last couple of years, so producing stuff. So let's get started. So first, what is OpenXR? So OpenXR is a open, single cross-platform, high-performance API between applications and devices and platforms. So going back to the history, how it was before OpenXR, you have the image here to the left, where you can see different proprietary APIs from different headset vendors. So if you needed to write an application that ran across multiple hardware, you needed to integrate several SDKs. That might have been fine, but then when a new device is released, guess what? You need to open up for new development because they might have had a new SDK. So going to OpenXR, you have the single API on the right-hand side, where you can target the API, and then the runtime implementer can actually make sure that the application translates this API calls to something that works on the hardware. So speaking about devices, here we have the current conformant devices. I'm sure you see names that you recognize. New for this year, or actually December last year, is that we have Android XR joining the OpenXR conformant devices. And they were actually conformant when they announced the Android XR platform. And I would also like to point out those Sony and Acer that does have spatial displays that you actually put on the desk, and they do stereoscopic rendering. And this shows that the platform, the OpenXR platform, actually can support a multitude of form factors. So this is our timeline of OpenXR. Back in 2007, the companies that were present in OpenXR then, or were working with XR then, felt that it was cumbersome with all of these proprietary APIs, and we decided that we wanted to grow the pie of compatible applications that could run on our hardware. So we formed the working group. A couple of years later, at 2019, we launched 1.0 of OpenXR, actually at SIGGRAPH in Los Angeles. And on day 0, we actually had 2 preview implementations showing that the standard is actually working. Then, for the years to come after that, more vendors were doing their 1.0 implementation of the OpenXR runtime, and also all of the major game engines implemented support for OpenXR. There were a lot of extensions coming out because everybody wants to transition to fully to OpenXR, so vendors made a lot of extensions to OpenXR in order to satisfy the developer needs, and that's fine. But then in 2024, we did the 1.1 spec update, where we integrated a few of the extensions into the core spec, and also did some various quality of life improvements. So we don't have a set date for 1.2, but you can rest assured that there's a lot of development going on. So we are exploring new features like body tracking, haptics, audio, spatial compute through spatial entities, and then also multi-app. So this is just a brief slide of the cross-vendor extensions and Khronos extensions that we did since the last year. The spatial ones are very interesting. I think that's been a core focus for a couple of years for the working group. And speaking of those, the spatial entities, like this is spatial compute through OpenXR, is brand new. It was released in June 2025, and this is a detailed API for the headset to reason about the user's environment that you need for this new XR devices. There are 6 new cross-vendor extensions. It has been a great collaboration in the group, both with the hardware vendors, but then also with the game engines. So actually the game engines participated in the specification and validated that everything should work. And since this is a framework, there are more data that's going to come through the spatial entities. Here I actually do have a video.
OpenXR provides us access to persistent anchors. All these objects are reconstructed from previously stored locations. We can place new objects and new anchors are created. A UUID will allow us to identify the placed object. We can move the object to a new location and the anchor is updated. Objects can also be removed. This logo object is physics and it drops down to the table. We can do the same with the plush. Notice how an anchor is created on drop and updated once the object stops moving.
Great. So, yes, awesome. And I think this was a success story because we actually, as a working group, we funded some development in Godot. And during the specification of this, we were actually able to put some money into getting this on preview implementation. So that's awesome. And we discovered issues as well, so it's a win-win. This was a fast forward. We also have the BAF. You will learn a little bit more about the spec update since last year. You will learn a little bit more about the special entities framework. You will also learn about the most compatible way of enabling mixed reality on headsets. You will also learn about GFX Reconstruct from LunaG, which is a capture and replay tool that supports OpenXR now. And you will also pick up some good topics to discuss with me and everybody else at the BAF and at the networking session. Thank you.
Classes for every occasion. Good morning. I'm Leonard Daly of Daly Realism. I've been with Khronos since 2019. I'm here to talk about glTF, which is also known as the 3D Formats Working Group, and also 3D Commerce. Okay. So 3D Formats is responsible for glTF plus a number of other specifications. Chose to call it 3D Formats because it deals with everything related to 3D formats. There's things like Collada, which have seen decreased uses. Also, the image container format KTX is managed there. 3D Commerce is dedicated to understanding the retail needs for 3D and has proceeded a lot in that direction. They don't develop specifications, but they rather get use cases and bring them over to 3D formats, and then also work with retailers and other people involved on the commerce side to make sure that the 3D objects can be displayed correctly and easily. Both groups, but especially 3D Formats, works a lot with industry partners, in particular ISO. The glTF core specification is ISO ratified. Working with OGC, Metaverse Standards Forum, which will have several BOFs today, this week anyway, and AOUSD, which is having multiple BOFs today, yesterday, tomorrow, and forever. I'd like to introduce Amanda Morgan, who is the newly elected vice chair. She was elected so recently that she didn't have a chance to put the presentation together. Otherwise, I would be her, or she would be me, actually. Okay. PBR is one of the longest running TSGs within 3D formats. It develops the physically based rendering extensions. You can see here examples of several of them, including sheen, index refraction, and several others. They also work very closely with Material X, AOUSDs, OpenPBR, and ASWF. Too many acronyms. So AOUSD, for those that don't know, is the Alliance for OpenUSD. ASWF is Apache Software Foundation, or Academy Software Foundation. And OpenPBR is OpenPBR. Some more material that they're developing. This is what they're currently actively working on. Real-time diffuse transmission and volumetric scattering. They have path tracer versions of these, and what you're seeing on the left is the path tracing versions. The very right is a real-time one for, Ed, help me please.
That's real-time diffuse transmission.
Thank you. Ed is chair of PBR, and he will be delivering a presentation later today. So this is a clip from one of the videos 3D Commerce put together, but it's to envision what we see as the ultimate use of interactivity as a product configurator, where the user can select different products, different configurations, different parts, different pieces to put things together. It's not at this stage yet, and Pratish will be talking about that later today. Go into the detail of what its current capabilities are. The specification for that is a public release candidate, and we're taking comments, and it's almost a release candidate. We're taking comments now before we finalize it. We anticipate to go into ratification by the end of summer. Physics is in the process of getting complete ratification. We have, at this stage, release candidate the implicit surfaces, which define things for collisions, and the next stage is the rigid bodies. This is illustrating collisions. It's a recording of a real-time rendering in Babylon using the Havoc physics engine. So this exists as an application right now. Owen will be delivering the presentation on that later today. Avatars is another subgroup working with the VRM consortium into developing the avatar standard formats. This work is done in close conjunction with VRM, and we have frequent participation or very regular participation by VRM members who are reviewing this and making sure things work together as before. The intent is to get a glTF version released with glTF standard extensions that is completely compatible with what exists now. Future may be a little bit different. And Ken, who will be delivering the talk, will be addressing elephants. Sean will be talking about 3D tiles, spatial data, and GLX, and an extended talk there. And this is 3D tiles as a means for representing and handling geographic data. So the geographic data that goes from everything from a whole city view down to the individuals, trees, and other features within the city, it becomes too big to display all in one chunk, and so you can move in and out through the tiles mechanism. And GLX is an extension of that idea where you can swap in and out pieces and parts without being trapped in by LOD requirements of switching. Gaussian splats is a new topic for things, and this work has really progressed a lot in the last year. About a year ago, it was just something that we were talking about maybe we should look at. Maybe we should look at nerfs, but splats is the one that got all the attention and has been progressing. We have a couple of candidate extensions to solve this issue. Hang on for a second. Get people seated here. And if that talk will be delivered tomorrow and on Wednesday by Adam and others related to splats and things. We'll have a couple top people who are talking about the details and the technology of splats in addition to the capabilities of the extensions. There we go. Okay, 3D Commerce has produced a number of videos, and this is just the title reel of 3 of them that were formed a series of delivering ROI, getting started, meaning getting started with 3D models in commerce, and tips for success. These videos run around 5 minutes or so. They're designed for the business person at the organizations to see how to go about including models in your presentations, in your website, in your product offerings, and making sure those are easily available to others. These videos are on YouTube. Everything here is publicly available for the amazing cost of $0. So 2 major presentations, one later this afternoon, right after this, 30 minutes after this ends, with detailed dives into a lot of glTF material. And then Wednesday is part of the Khronos Development Day series in the morning from 10 to noon, 2 hours talking about other parts of glTF and looking especially at roadmaps and where we're going in the future.
Hello, everybody. I will present a few updates on both the WebGL and WebGPU APIs. On Wednesday, Kai Minamiya from Google will present the WebGPU updates in more detail. So, we'll start the timer to make sure we're on the time. Doing good? You are? Good. All right, so before we get started, everybody likes cool 3D demos, so let's try. Let's work before. All right, here we go. All right, this is silly. Where's the... All right, so this is soft body Tetris, and you can imagine how on earth does this work, because you're not going to get horizontal and vertical pieces or lines anymore, and it's very, very silly. So this is written in Three.js. It's using WebGPU. This is already out there on the web. Khronos is going to publish the slides later today, so you can just click the link and run it on your machine. And if you're on the SIGGRAPH Wi-Fi, you'll probably take 10 minutes to download the 5 JPEGs that are the materials for these things. Anyway, so it's written using Three.js and the new Three.js shading language, which was necessary in order to abstract between GLSL and the WebGPU shading language WGSL. But now that that's written, you can write compute shaders in a portable way. You can write all of your materials in a portable way. And the Three.js developers realized that until WebGPU is totally pervasive, you're going to need a WebGL fallback for a lot of this stuff. And so they've actually built into the WebGPU backend for 3 a WebGL2 fallback for a lot of the functionality. Maybe not like all the compute shader stuff, and that's what the soft body simulation is using here. But anyway, they have been working on the ecosystem so that whenever we upgrades to the latest Three.js, one day when all the browsers support WebGPU solidly, bam, we just switch over and everybody uses WebGPU automatically. So because you were already using the WebGPU renderer yourself. Anyway, this is just a little silly preview, very fun stuff. I want to thank Nicholas Nihus who put this out. Okay, so anyway, all the links are there. And let me get the mouse pointer out of the way because that was driving me crazy earlier. All right, so Khronos and W3C have been collaborating for a very long time on both the WebGPU, WebXR standards in particular. Nowadays, XR applications and engines have access to line functionality across native and JavaScript APIs. You can see here, Three.js and Babylon.js are 2 of the top web frameworks out there, and they're built on WebGL, WebGPU, and they both have WebXR support. And these things bottom out into other Khronos standards such as OpenXR and Vulkan and OpenGLES. So through this nice collaboration, we've gotten web standards that run everywhere on like all hardware, and you can write an app and trust that it's going to run both on your high-end, desktop GPU and your mobile phone, and really everybody's mobile phones, and that's the point. So, brief WebGL update. So first of all, again, Khronos is fully supporting the development of WebGPU over at W3C. And everybody's working for a smooth transition between these ecosystems. Neil's fond of saying that he doesn't want an Osborne WebGL yet. Does anybody know what that means? It's a great computer science story where the Osborne was a very successful computer, and Mr. Osborne announced like the next version of his computer, and everybody waited to buy the next one, and his sales tanked, and the company went out of business before they could produce it. It's a real life lesson. So we are fully supporting WebGL. It's going to be supported forever. And you can already, of course, start using WebGPU and deploy stuff. Provisionally, you have to basically test for support for the API. But WebGL is everywhere. It's going to be out there forever. And we are evolving the WebGL specification and supporting multiple implementations. We'll talk more about that at the BOF on Wednesday. I did want to point out that Kelsey Gilbert retired from the WebGL working group this year, and we have a new working group representative from Mozilla, Ashley Hale. So thank you, Kelsey, for many, many years of dedicated service to WebGL, and Ashley, we are already enjoying working with you and looking forward to many more years. Okay, so a few highlights. We're still working on, for example, Angle's Metal backend in collaboration with Apple to make it more correct in performance. So if you're seeing WebGL 2 running better and better on iOS, this is why. Firefox is actually now considering using Angle Metal on macOS so that they'll get off the OpenGL driver, which is really not maintained anymore there. In Chrome, we're continuing work to use Angle everywhere on all platforms for correctness and the expanded feature set. And there's been more recent performance work on the Android platform, which is the last holdout. That's where we're not using Angle yet. And we think that we might finally be over the hurdle there. The Pixel local storage extension that Chris Dalton from Brive has been championing is progressing. There's now agreement on all browser vendors on the form of the extension. That was a big relief. It took a long time to get there. There have been some recent cleanups and refactors. We deleted enum, and we compacted the enum space. Boy, you wouldn't believe how many change lists were needed in Chromium to make that work. Do you know we have 3 copies of GL2.h, that header, in the Chrome repository? Well, I didn't, and I fixed 2 of them, and I wondered why it wasn't working on that, and I found the 3rd. It's software. So anyway, there are 2 more fixes for this extension. One is for fixing some of the validation, and one is for non-coherent Pixel local storage that's supported by some hardware, and then it'll be ready to ship. So finally, we'll get sort of user programmable blending in WebGL. Also, now there's a consensus among all the browser vendors to finally ship the base Vertex base instance extensions. And if you remember the almost zero driver overhead initiative in OpenGL, from many years ago, we're sorry this took so long, but this is very important for getting that, to be able to compact a bunch of shapes into the same Vertex and index buffer. So anyway, after a couple more bug fixes, this is going to be ready to ship too. Now, GPU. This is the new generation API. It's cross-platform GPU graphics and compute. And it has multiple backends, Direct3D12, Vulkan, Metal, and there's a big asterisk here, OpenGL ES3.1. I'll talk a little bit more about that. It's not the full API, but it does work. And of course, this is supported by all browsers. All browsers are at the table specifying this. And there's a new shading language, WGSL, the WebGPU shading language, and we have one representative from Chrome's shader compiler team, Dan Sinclair here, and so please talk to him after the BOF if you have any questions about how that is working or is implemented. So this is an architecture diagram. I'm just going to breeze over it, but basically you can see that WebGPU is going through a bunch of different browsers, bottoming out in multiple implementations. And one really cool thing is the mscripten path, where you can basically take your C++ application. Okay, you can write it using a standardized C or C++ API for WebGPU, and then recompile that thing to the web, and it just runs. That's what we had in WebGL with the mscripten bindings to OpenGL ES, and now the same thing is there in a multi-vendor standard for native applications. And there are multiple implementations of that, by the way. You can use Mozilla's Rust-based WebGPU native implementation and still compile with the mscripten toolchain after the fact and get your C++ app, or Rust app, I think, up on the web that's using WebGPU. So anyway, this is a very cool progress, and actually Kai worked extensively over the past year with others to standardize that WebGPU.h, that native header for the API. And that's basically done. So thanks for a lot of dedication there. All right. So a few updates, and credit to Kai also, who wrote this for the Wednesday BOF. I've excerpted it a little bit. So Firefox shipped WebGPU on Windows. So awesome. Kudos. Anybody here from Mozilla? Well, thank you, Mozilla folks, for getting that over the finish line. Other platforms, they are coming soon. WebGPU is actually already on in the new macOS and iOS betas inside Safari. But you can try the Safari Technology Preview on the current operating systems as well. We continue to collaborate with Unity on their WebGPU export path. So you can just have your Unity game and export it to WebGPU, and all your compute shaders and stuff all work just fine. They report that the WebGPU exports are running well in all browsers now, which is awesome, because they're touching most of the API surface. And Google and Unity are collaborating to officially support WebGPU and Unity to get the marketing folks to take off the experimental flag. But a little while longer, I think, and let's get all the browsers shipping WebGPU and passing the performance suite 100%. In Chrome, a new intermediate representation in the shader compiler is delivering much better compilation performance, and kudos to the entire compiler team for delivering this on all platforms. They had to do it for Windows and Metal Shading Language and Sphere V, and now that that's done, there's just really solid compilation speed everywhere. And there's a lot of other work ongoing throughout Chrome's WebGPU runtime. I can speak for our team only, especially for better performance and lower latency. All right, so I did mention that this stuff runs on OpenGL ES 3.1. There's a new compatibility mode specification. It's basically a small subset of the WebGPU overall spec. It carves off about, 10 or more sharp edges where OpenGL ES 3.1 didn't support, but say Vulkan does. And you can go onto the website to see the biggest, of these differences. One is that you have to change your mid-map generation code in compatibility mode. You can't just operate on arbitrary textures. You have to know the texture type, because that's defined up front in OpenGL. It's not a big deal. And if you target compatibility mode when you're writing WebGPU, you're going to run everywhere. You're going to run eventually on all devices that support WebGL 2, pretty much, or like 90%. So this is the way that we're going to get WebGPU to be pervasive everywhere, especially on older Android devices, older, say, Chrome OS devices. So the standardization of this is really done. Most of the spec changes are already in and have been approved by the working group. They're going into a branch, and then when that branch is done, it's just going to be folded into the core spec. It really is done. Now, a teaser for the BOF, I'm not going to go into the details here, but Jeff Lang, who's the Angle TL, and I'm quite sure one of the co-founders of the Angle project back at, not sure.
Sort of.
And Carton Valle, who is the WebGPU TL and largely initiator of the API, and Chrome security team have been collaborating on this little project. So Angle is widely used as the native WebGL implementation in browsers. It's a C++ project, and it contains the OpenGL state machine, or the GLES state machine, and implements it on top of other APIs, like Direct3D11, for example. So, given that Angle has so many backends, what if Angle had a native WebGPU implementation backend? I mean, the WebGPU implementation has Direct3D12 backends, and a more modern backend. It has its own metal backend, which is slimmer than what is in Angle today. And it really makes you think, hey, what if we could rehost that whole OpenGL implementation on top of WebGPU? And there's a lot of interesting properties that would come out of this if it came to fruition. So for more details, if you want to brainstorm about it, please do come to the WebGL and WebGPU BOF on Wednesday, which is the first one of the day, bright and early, 9 a.m. over at the Fairmount Waterfront in the Waterfront Hall. And looking forward to seeing you there.
So we're pretty much on time. So we have like 20 minutes for Q&A. So What are all those tricky questions you've been saving up for the chairs? We can bring a mic to you. Any questions from anybody about anything?
Testing.
Anyone?
Hello, thanks for all the presentations. I was very curious about the ML API that they developed. Will it allow importing models and standard formats like OpenXR or EKL or all that? Is there a pathway for service?
Markus?
I didn't fully get the question. Can you hold the mic closer?
So sorry, I wanted to know if, for instance, with the future API for AI graphs and tensor graphs, we'll be able also to use existing OpenXR models, for instance, and just have an easy way to say, okay, I have this OpenXR model, I want to perform inference on it. Will it allow this kind of behavior?
Well, there's no decision yet on a new API or integrating it into an existing API. So within Khronos, Vulkan is getting some way to integrate a lot of stuff. So potentially this would be one way to go. Maybe the OpenXR team has interest as well. The more interesting part is how to expose this PLV part of getting a hardware abstraction layer for machine learning instead of relying on external compilers only, because the compiler knows only the hardware at the time the compiler is being shipped. So even if you would have an application, integrate the compiler into your application to compile for whatever hardware you have. If you get new hardware, the compiler doesn't know what's new hardware and it can't generate optimal code. And this is one piece which is currently lacking in the ecosystem. We need a hardware abstraction layer so that the driver by the hardware can compile exactly for the platform. And once this is there, we integrate it wherever we need it.
Thank you. Any other questions? Let's raise your hand. Yeah, thanks.
I'm interested about like
About
the machine learning stuff.
Yeah.
It's kind of interesting how machine learning can play a role in like a lot of more stuff like perceptive AI and classificatory stuff. And physical AI is pretty interesting, but I wonder, how that really plays into like the standards you work on now.
Yeah. So I think you're absolutely right. I'm sure many people here are aware we're on the verge of a machine learning AI revolution in pretty much everything we do in the whole domain of 3D, not just 3D, but spatial computing and the metaverse. Everything about understanding environments, understanding users with language and gestures, semantic analysis of the scene around us, so we can begin to bring AI into the real world, and we can be training AI in virtual spaces. The worlds of graphics and AI are intimately linked, and as Markus has been explaining, it's actually very interesting what the hardware community in Khronos needs to do. That's why we're putting so much effort into trying to intercept all of the work that's ongoing, all the research, and saying, okay, how can we bring pervasive, cheap, effective hardware acceleration? So far, we haven't needed to create a new API, but we have low-level hardware APIs that are providing compute acceleration. It's still an open question though. Are we going to be able to build what we need into those APIs, or are we going to need new APIs? So we still have an open mind about that.
Of course, I went to a thing, one of the labs handled by NVIDIA about training physical AI using what was essentially graphics technology and
Yeah.
Isaacson. So, and that was pretty interesting. So,
Yeah. I mean, Shannon, the Slang is at the intersection of graphics and AI, and you briefly mentioned glTF and other stuff. You want to say just a couple of words? What are people doing first, in your experience, at this kind of emerging intersection?
So I think the answer to that mostly depends on which direction you're coming from. There are a lot of people who approach graphics from the machine learning world and will probably bring with them a lot of knowledge about Python and working with large data sets. There are also lots of people who are just encountering machine learning for the first time, coming from the graphics side. And those folks might be looking at, how machine learning can be applied to develop new techniques to solve some of the problems that we've been facing in graphics for a long time. I personally, with the Slang team, have worked on kind of some easy introductions to machine learning to address issues of, optimizing textures for, compression or mid-mapping, things like that. But there's people coming to the space from different directions, so what they do first really has depended on that.
Mm-hmm. Yeah.
One of the most freaky demos I saw, it was related to glTF, and what was machine learning was a demo at Vulkanized, which was running a textured glTF model, 180 megabyte textures. There was no texture at all. All those textures were coming out of a little neural network. And it just looked identical, and the size was 5% of what you needed otherwise. This stuff is going to revolutionize a lot of what we do. So it's going to be fun times over the next few years. Question? Yeah, go ahead.
I got a quick question for Leonard. For the glTF, the presentation you were talking about for the 3D tiles and the geographic terrains, who's going to be presenting that, or what is the session they're going to be talking more in details about it?
You see, there's 3 sessions that may fit into. The first one is this afternoon, and it's this one right here. The next one, the splats, and there'll be some referencing here, will be on Tuesday morning. Room 8 is through this wall. And then Wednesday, 10 to 12, they'll be talking about splats and GLX and 3D tiles, those 3. Thank you.
Yeah, and that next one is right here at 12. So, yeah, go ahead.
So, I apologize if this is not the right question, but how do we get to stay in front and contribute to all this standardization and framework development process if we're interested in that?
Well, the question was courses, did you say?
I mean, it's both on the side of how do we stay in front on this, and how would we be able to help contributing to this development?
Okay, that's a great question. So we try to have many different ways to stay engaged with Khronos and figure out what's going on, what's happening. So it's like an onion ring. At the middle is Khronos membership, but of course we realize not everyone can or wants to join. But it is worth saying, any company, if any of this stuff is relevant to you and you'd like a voice, a full vote in how things evolve, we are an open organization and we actually thrive on people getting engaged. So if your company is remotely interested in any of this, please do consider joining. It's not that expensive. We do need to charge because we are a non-profit. That's what keeps the lights on. But if that's too much, then we have advisory panels where if you are active in a particular domain and one of the working groups is interesting to you, but you can't join for good reasons, then come talk to us. We have advisory panels where we can bring you in to the discussions, and that's free of charge. We have online presence. You go to the Khronos website, We have forums, we have Slack, we have Discord for most of the working groups out there. We welcome questions and discussions there. Most of the specifications are developed in the open on GitHub to varying degrees. And if you're willing and able to contribute to the specification process itself, either bugs, if you're using one of our APIs, you find bugs or issues, go to the GitHub repos, and we'd love to converse with folks there. And we try to do physical outreach too, like this event here. We go to SIGGRAPH Asia. If you're in Asia, we go to AWE for the XR crowd. We have our own conferences organized. If you're into the 3D side of things, the next organized is in San Diego in the spring. We're actually doing a shading language symposium, which is co-located with Vulkan, which is all of the shading languages, all in one place, all at one time. It's I think the first time it's ever happened. So we're organizing that. That's going to be in San Diego the day after Vulkan finishes. So, and come talk to us after, and we'd love to point you in the right direction. We'd love to get you involved.
Thank you.
Yes, over there.
Yeah, did you say the name of the web GPU shading language was Wixel?
Yeah.
Is it compatible with SPIR-V standard?
It was actually designed with the SPIR-V primitives in mind.
Okay.
There was a big discussion early on in the web GPU standardization process of what we couldn't just use GLSL because it wasn't really evolving at the rate that was necessary. And there were some ideas from different companies on what should the new shading language be. So actually, the way that it started was it started from the SPIR-V primitives because those are the only cross-vendor, cross-platform primitives known to work in the shading language. And then it was up-leveled to a textual form and evolved over a period of months and years, and now that's what it is. So
Yeah, that makes sense. Yeah, as long as it's compatible with SPIR-V.
It definitely is, and there are SPIR-V readers and SPIR-V writers for Wixel. Tint has both paths, and Dan mentioned that they're working on the SPIR-V reader right now, bringing it over to the new intermediate representation, at which point you'll have an open source tool chain that can import and export SPIR-V from Wixel, and you can use that offline, or online actually, in WebAssembly.
I actually learned a new word about this, is bijective. I'm really proud of myself, because it means it just goes backwards and forwards really easily, I think. Yeah, go ahead.
Is this?
Yep, it's on.
I think I just turned it. Okay.
There you go.
There. Are there any plans to keep older specifications like OpenGL alive, similar to what you were saying with WebGL earlier, where it would just stay around and supported on all the browsers?
Yeah. That's a great question. Thank you for asking that. We should put it like a public service announcement at the beginning of every Khronos presentation. OpenGL is not going away. OpenGL is going to outlive me for certain. So it's going to be around for at least another 20 years. It's been around since 1992. It's used everywhere. Yes, all of the cool new apps are writing to the more modern APIs, but there's so much software that's out there. So all of the hardware vendors that shipping OpenGL, there are no plans to ever stop. So yeah, you can keep using OpenGL for as long as you need, and then transition over to the newer APIs if and when you need to. So certainly a lot of the newer functionality is going into the newer APIs. So ray tracing perhaps is one of the biggest examples, and a lot of the ML acceleration stuff probably will be oriented around the SPIR-V more modern APIs. So yeah, the new stuff will go into the newer APIs, but OpenGL's not going away.
So is the approach that you'll end OpenGL support or vendors more likely will end OpenGL support when there isn't really any software that uses OpenGL anymore, or is it that you
eventually
literally never plan on ending OpenGL ever?
Yeah, I mean, eventually the universe will end, heat, death, and everything.
Yeah, but
I mean, eventually there will be literally no one who needs it anymore, and of course then at that point. But it's at least decades away, I think.
I feel like some people would be interested in at least still playing older software, being able to support that, still being able to keep older software alive. As long as people care about it.
Yeah, and there's code bases out there that will never migrate. So, yeah, then we need to keep it supported.
Yeah. People still write in COBOL.
So, one thing that's maybe worth saying on the GL situation is there were some references to Angle in the WebGPU talk. Angle is a software layer that will let you run GL and OpenGL ES on top of Vulkan, and before anyone panics about performance, like I saw some numbers just last week that said for a certain class of apps, like the Angle performance is better than people's native drivers. So even if you get into a world where hardware vendors decide maybe they don't want to invest in their drivers, as long as Angle exists, as long as there is a software emulation path, and there's a lot of engineering going into that path right now, there will still be something that matches the spec. You'll still have a path to running that content. And yeah, right now, some of that stuff is faster through that layer than it is on the native drivers.
Yeah, that's a great point. Thank you, Ralph. It is a trend, right, that layering and having a concentrated number of lowest level HAL APIs is kind of the growing trend. It's very interesting that Ken was bringing up that maybe the same thing's happening in the web space now too. It makes perfect sense. Because the hardware vendors don't have to support a whole bunch of different drivers. The layers are in open source, so they will never go away. They're not under anyone's control. It's a win-win. Okay, any other questions? Yes? Time for one more, so you go to the last question.
Okay. Hi, I have a question for Shannon about the Slang. So I took the Slang course yesterday and very impressed by how Slang adopted the NumPy, cooperate with NumPy, and I can see that engineers with more ML background will be impressed, and because they can use NumPy and feeding the data. And I have a question from the ML console section where you have an API proposed about the tensor shader and tensor ops. And I wonder if that's the direction that the Slang can start to adopt the ML. And what's the consideration or obstacle that you're facing? Is it because you're still trying to research and model how the engineers want to use the Slang as an API? Are they comfortable with this tensor exposed to them? Or is it because all the backends, they have different progress on adopting those underlying implementations? So that's my question.
So that's a big question, and I think the answer deserves a lot more nuance than I'm going to be able to give you. But the good news is that at the BOF on Wednesday, there are going to be a bunch of people in the same room who can probably give every bit of nuance that's needed. So Young-He will be talking at the Slang BOF about the future roadmap of Slang, and we'll start to touch on kind of the plans that we started building out towards a future that can support things like tensor operations or heterogeneous shading language support. And our BOF is directly, I think we're directly before the ML Council BOF. So that's probably a really great time to find all of the experts in one place and get lots of answers to to exactly that question, but I think I can answer intent is like we're really interested in exploring that. There are a lot of things to do, and we haven't necessarily had the resourcing to really dive deep down that rabbit hole yet. Does that answer your question?
Yeah, sort of. I will attend tomorrow's walk.
Wednesday.
Oh, Wednesday.
Yeah. Okay, great. We'll see you there, and I will make sure that Young and Markus together can answer your question.
Yeah, that's great. Thank you.
Awesome.
Please come. We need your input. It sounds like you're active in the field, so please come and let us know what you would like to see too. And we're in that discovery phase. So, okay, thank you everyone. I'll let you all go. Have a great rest of the SIGGRAPH. Thank you.